right, let's take a look at parallel and series circuits. First of all, let's begin with a review of what is a simple circuit that we've already discussed a little bit. Remember that a simple circuit is made up of a power source, one load, and some connecting wires. If a circuit has more than one load, it's not a simple circuit anymore, and we have to start working through whether that circuit is series or parallel, or sometimes a mixture of both. Let's begin with a series circuit. In a series circuit, there is only one possible pathway for the electrons to follow. What do we mean by that? Well, if the electrons leave the power source, if you have a look at the blue oval that you see there on your screen surrounding our circuit diagram, you'll notice that there is only one way for the electrons to return back to the battery that they came from. There's only one possible pathway for those electrons to follow. They all travel the same circuit, and that's what makes this circuit a series circuit. Before we leave this diagram, let's talk about some of the symbols that you see there in the diagram, because those are important. Those are all accepted standard symbols for the sorts of components that you would find in an electrical circuit. And you will be responsible for learning those symbols and being able to apply them. So let's take a look. First of all, we have a battery. The symbol for a battery is a series of short followed by longer straight lines, repeating over and over and over again. So you can see in this battery, there's one short one followed by one longer one, then another short one followed by another longer one. So there's two pairs of short and long lines. The more pairs like that you see in a battery illustration, in a battery diagram, the more volts that battery is giving to the electrons as they're leaving. That's the accepted symbol or diagram for a switch. Switches, it's easiest to draw them if they're already in their open position, because then you can clearly see what is a switch and what's a connecting wire. We'll come back to the connecting wires in a second. This series circuit has 3 lamps or light bulbs or light globes all connected up. And so they are all made to light when we're connected to the battery and the switch is closed. This is one possible way to illustrate a lamp or a light bulb, but there are several others. Finally, the straight lines that connect all of those other components together actually represent the connecting wires that link all of our components together in the actual circuit on the bench. I also want to draw your attention to the way that the straight lines in this diagram are all very straight, and they've all been drawn with a ruler. Also, in the corners of the circuit, the corners actually meet, and the connecting wires touch each of the components. There are no gaps between the battery and the connecting wires, or the connecting wires and the lamps. They actually touch each other. And that's very important, that when you draw circuit diagrams, you draw them with rulers, but you also show them unbroken all the way around the circuit. You show everything touching one another. That's really significant that you do that in order to be able to be awarded full marks. Also, of course, because this is a scientific diagram, when you draw one for yourself, you will draw it in pencil, please. Parallel circuits. Now, parallel circuits look a little bit more complicated. In a parallel circuit, there's more than one possible pathway for the electrons to follow. But the electrons will only follow one of those pathways. So if there are 50 electrons that set out, say 50, that means that you won't get all 50 covering every possible pathway, doubling back on themselves. They can't ever double back on themselves. So they'll have to divide themselves between the possible pathways. Let's look at a diagram. There is a circuit diagram for a parallel circuit. Now you'll notice that the battery here is smaller. There are still 3 light globes, but they're wired up very differently. They're wired up in a way where there are 3 possible pathways for the electrons to take. The electrons could take this red pathway, leaving the battery, traveling through the first globe that you see, and then returning back to the battery. Or the electrons could follow this blue pathway, leaving the battery, ignoring the first globe, and passing through the middle globe before returning to the battery. Finally, there's a third pathway, this green pathway. Again, the electrons leave the battery. They ignore the first and second light globes, and instead they pass through the third bottommost light globe before returning to the battery. So those are the 3 possible pathways that the electrons can follow in this circuit, and that's what makes the circuit parallel. Tomorrow, we're going to look at a number of circuits, and you'll try to work out whether they are simple, series, or parallel.